Hi, welcome back to my channel Techie Blossom. I am Pratik Sharma and I will be sharing my experience on Android app development, how I started and how Android changed since its inception. I will speak on how current Android development is done, like using what libraries and what all best practices are being followed. This video is for those who want to start or are new to Android development. And for experienced developers as well, you will get to know what is a trending way of creating Android applications in current era. So let's get started. This video is divided into following sections. First, I will quickly speak on my journey and experiences and learnings from my initial days. Second, I will walk you through Android history. Third, I will touch upon Android Studio's basic folder structure for an Android project, where you will find GRADLE, resources, KOTLIN files, and some Android Studio IDE features that are very useful while developing Android applications. Fourth, I will walk you through ways of creating UIs in Android and managing states in all of those techniques. Fifth, I will explain how you can make network calls or how you can interact with database to create real-world applications. Sixth, I will touch base upon clean architecture, which is very important to develop any application. Then I will talk about dependency injection. And lastly, we will see some more Jetpack libraries which will be useful in app development. So let's jump to my journey. I started Android development way back in 2012. I read official documentation multiple times to understand the concepts very clearly. And in that process, I created 2-3 applications to put whatever I was reading into practice. You can say that those projects were pet projects. One of the applications that helped me most in learning Android concepts was Group Extension Manager. I deployed it, I created backend for that also, and I published it to Google Play Store. Let me tell you, it was not easy to finish that application because while I was developing the application, I wasn't aware of recommended architecture and recommended libraries to use. Or to be honest, I was not sure whom to trust, which blog to follow, because many blogs had different opinion and used different libraries to solve that purpose. And I was not satisfied with any of the approaches that I used to create the applications. So I wrote the application 2 or 3 times before reaching to a conclusion. In those days, Eclipse IDE was the preferred IDE which was used. Around 2013-14, Android Studio was launched. Google announced it as a recommended IDE. Google also stopped publishing plugin updates to Eclipse. So, I had to migrate my project to GRADLE system, which Android Studio follows. I was not much experienced with GRADLE system, so I preferred creating a new project and move my code from Eclipse or Ant system to GRADLE system by copying every file and pasting it in Android Studio. I was naive back then. To be honest, I was very lucky to witness so many changes in Android ecosystem since I started till today. There was change in whole UI system, like from Gingerbread to Holo, Holo to Material. And now you also see Material to Material U, which is Material 3. Not only this, I witnessed changes in approaches from Android team as well, like from single activities with fragments to multiple activities. Eclipse to Android Studio, from no architecture to ever-changing architecture. And not to forget, Java to Kotlin. When it comes to learning the things when you do self-learning and experimenting, the list is endless. And that's the most beneficial part of self-learning. But now, things have changed. Android team has taken the responsibility on their shoulders by introducing Jetpack libraries. Jetpack libraries is a set of libraries which you will need in any Android application. These libraries will do the heavy lifting and you will be given abstract APIs to use in your application so that your application always follows best practices which are recommended for Android OS. All of the libraries which fall under Jetpack umbrella are compatible with each other. I bet you that there is always one library in Jetpack for you to use in your Android application for your use cases. If it's not there in Jetpack, Android team has acknowledged many third-party libraries which are recommended on Android official documentation like Retrofit, Glide, and many more like this. You might have heard of Retrofit probably, because it is used to make network calls. In this video, I will walk you through how modern Android development is done. The libraries that I will show are backward compatible till API level 21, that is Android Lollipop. Speaking of Android version, now let's move to the second part of this video, Android history. In 2008, Android 1 was launched. Till 2010, there were multiple versions like Donut, Cupcake, Eclair, Froyo. Notice the names of these versions. They are named after a sweet eatable item. In 2011, it was mostly gingerbread and ice cream sandwich. At this time, I started learning Android. Back in those days, gingerbread was very popular, and I remember 2 of the Samsung phones were launched and they became hugely popular. Because it was very popular, you can say that many people started buying Android phones, and we can say that Android had caught eyes of many end users. By the end of 2011 and start of 2012, Ice Cream Sandwich was launched with hollow design system. That was the time when Nexus 4 was launched. You can say that was Google's flagship, a very popular phone that had vanilla Android OS. This was the time when tablets were very much in demand, or the concept was just launched, and Android system, Android OS honeycomb version was released just to address tablet phones or tablets. From 2012 to 2013, Jelly Bean OS came into picture to stabilize Android OS. Here, Google Now was introduced, which we now call as Google Assistant. At the end of 2013, we saw KitKat version, and with that, we saw the launch of Nexus 5. I bought that phone, and that was a very sweet phone. It was LG's hardware for Nexus 4 and Nexus 5. This was the time when support for watches started. That's why with the KitKat we saw a version called 4.4W. That means the OS is for watch. 2014 was all about KitKat, but at the end of that year, Lollipop was launched, and with the API level 21, to which all the Jetpack libraries are compatible with. Here we saw new library for design, which was Material Library. So this means that this release was a big release for Android OS. With this release, we saw launch of Nexus 6, but this time the hardware was from Motorola. I can say from Nexus 6 onwards, the Nexus lineup degraded itself. We can blame on Motorola, maybe. From 2015 to 2017, frequent updates were there, like Marshmallow, Nougat, Oreo, which started M and O. So if you see, Android versions actually followed alphabetical order, and every version was named after an alphabet, like Marshmallow, then N, Nougat, and then Oreo. These all versions actually focused majorly or mostly on the permission system that Android OS has. It added more security to Android OS. With Nougat release, we saw rise of Google Pixel phones, which we now see Pixel 6 or Pixel 7, recently announced in 2022. In 2018, Android Pie was launched. In 2019, Google stopped naming the versions, probably because at the end they will reach to the end of sweet items, eatable, reach the end of alphabets. So they decided to call the Android OS with the number itself. So we saw launch of Android 10. 2020 was for Android 11. 2021 was the launch of Android 12 to support foldable devices, tablets, and desktop sizes screens. Android 12L was also launched. So in 2022, we are expecting Android 13, which is recently announced as Android 13 Beta, is there for developers and you can use it. So by the Q3 of 2022, we might see a stable version of Android 13. That's the whole history of Android versions, how they started, what all changed throughout these years. I feel every developer who is starting new in any technology should at least know a little bit history about OS or about that technology or that framework. Like if I want to start iOS development today, I would like to know its progression over the years. So now let's jump to development part. Remember, I am giving an overview of Android development as there is a lot of depth in each of these topics. If you want to know details about these topics, which I will just cover, let me know in the comment section so that I can create videos in depth to teach you about those concepts. So let's jump to Android resources. So what are Android resources? That's the first question that should come to your mind. If you are already an app developer, you might have used images, colors, some styles, animations, transitions, etc. Translations also when your app supports multiple languages. In Android, they are called as resources. You will store images, translations, animation files, shapes, colors, styles, etc. in a folder called res, which is located under source main folder. So when you create an Android project, you get res folder by default in your Android application. You also find some predefined folders, subfolders of res folder. Let's see what all those folders are. The drawable folder is responsible for vector images, PNG images, you can say WebP images, and XML files which define shapes, like backgrounds or foregrounds of UI item. The MIP-map folder is the one which keeps launcher icons. You will find suffix to these MIP-map folders like XHDPI, XXHDPI, HDPI, MDPI. What does that mean? This is because you are supporting multiple dimensions, multiple form factors, multiple phones who have different PPI, which is pixel per inch. So the compiler, when it creates a build, it uses resources for that specific density group only and not all these. So it doesn't mean that your app will be shipped with all these launcher icons for all the irrelevant images that you are putting it in the folder structure. When you download the application in your phone, you will download only those resources which are relevant to your phone or your phone density, right? So it won't be downloading unnecessary resources that it doesn't have to show in the UI. Hence, using less storage and less runtime memory. Now let's move to another folder, which is layout folder. The layout folder, by the name itself, suggests that you will be putting UIs in here. Since Android's launch, developers created UI using XML and associate it with a Java or a KOTLIN class to access and update UI elements. Nowadays, with reactive and declarative programming, we have Jetpack Compose, which is again under Jetpack umbrella, but it's a whole redesign of the UI system. You can say it's a new UI system which will eventually replace XML, and then you will have only composables that will be able to create the whole screen for your application and multiple screens for your application. Now in the layout folder also, you can see suffixes. You can actually add suffix. So let's see some examples what all suffixes can be added to layout folders or any other resource that you see like drawable values, which we will talk in later. So for example, layout-sw720dp, which means that it will contain the files present in this folder will be used when the phone's smallest width is 720. Layout car, layout night, the name itself suggests that car's XML UI will be used in the automotive application that you create for cars. Night will be used when there is a dark mode or night mode. The list goes on, and you can actually apply more than one configuration to a specific resource. And in this order which is shown on the screen, this is from official documentation. I have shown you examples for layout resources, but you can apply the same concept on drawables and other values. Now you might be wondering, how do you use these resources in your Kotlin or Java classes when they are defined at multiple places? So how you can refer to one instance or one resource of suppose English type or landscape type, if there are multiple resources defined, how you can access one of them. So let's see. Imagine you have main.xml in two separate folders, layout in English and layout France. You will access your main.xml, which is automatically compiled for you and a reference of that file is put in a R file. So you access that file using r.layout.main. So there is no need to specify the configuration because the compiler has created an alias for your one main.xml file or for both the main.xml files, and the language specific file will be loaded when your locale or your phone's locale is set to English or France. And similar concept applies to all the drawables, all the other values which are there in the res folder. Now next, move to the values folder. The values folder contains values like int, string, colors, all constants which you can define in your application. And if you have multiple languages supported, then you can define values also in different strings, different translations. So you will have multiple string files defined in different values folder. So based on your locale, the same English or same translation of that text will be used in your application. And whatever constants that you define in values folder will be accessible at the compile time. You need not run the application, you just have to compile it and you can use it in any of the composable or any of the Kotlin class. So the last one in this regard is Android manifest.xml that holds your activities, services, broadcast receivers, etc. So activities are nothing but you can say a screen which is visible on your phone or your app is an activity. Of course, fragments are also there which are a part of your activity, which you can say your activity can be subdivided into fragments and then fragment will have its own life cycle. You define permissions in the Android manifest which your app will use, like network permission, like SMS reading permission, like call history permission. So you have to define in your Android manifest that your app needs these permissions. That was all about Android resources. Now let's move to Kotlin or Java files. So where you define them and what they do exactly. You will keep your Kotlin or Java classes in src folder. There you have a main folder and then you have a Java folder. It doesn't matter whether your file is Kotlin class or a Java class. They both will go in the Java folder only. Now here you have complete freedom to structure your code base. You follow clean architecture or you don't follow, it's all up to you. You can create n number of folders, n number of methods in them, n number of files in them. It's up to you. The source folder is empty. By default, it has just a single main activity.kotlin or Java file, which is a landing activity. If you have created the project using the wizard and you have opted for a default activity for your application. So that's why. Otherwise, you can create it at a later point of time. So mostly clean architecture is followed and it is being recommended by Android team as well. They have created a whole set of documents that teach about clean architecture and how you can use it in Android applications. If you want, I can cover in detail with the help of an application, because I am right now working on that application or on an application for teaching purpose. So if you want, I will definitely put more effort in that, and definitely I will know that some people are waiting for that tutorial to come. So I will be more motivated into that. So as per clean architecture, you should be having a domain folder, data folder, and a presentation folder. Layers basically. Domain folder as per Android team is optional, but ideally you should have it because it helps you in understanding or creating boundaries from data layer to UI layer. Later in this video, I will be explaining in more detail what goes in data layer, what goes in domain layer, and what goes in presentation layer, how these layers interact with each other to form the complete clean architecture. Anyway, you can create more than 3 folders as well. It's not a bar. I generally create a dependency injection folder where I write modules, components which are dependent on each other. So I define dependencies which are later used in the application. Now is the time to check the last thing and the most important thing, which is a GRADLE file. So every project has 2 GRADLE files because by default in Android project you have a app module which is used for mobile applications, and there is a project GRADLE file as well. In app module GRADLE file, you generally define dependencies which are used by your mobile application, and that source code will run on mobile application. In the project GRADLE file, which is a global file, and we can define multiple common things which are used in these module GRADLE files. So we can define some version numbers of some libraries, class paths we can define in the project GRADLE files, which will be used by the module GRADLE file. As I said, app is the default module. Similarly, if you are creating your application for watch, then you will have another module, name it watch, or any other library which is a UI library, then you will have another GRADLE file. So all these modules will have their own GRADLE file and the whole project will have one GRADLE file. If you're new to Android development, then perhaps you don't need to dive deep into this. Gradually you can catch up on this, and most of the time the ID will itself help you in changing these GRADLE files or updating the GRADLE files just by the click of a button. You might not write code as well. Okay, so speaking of IDE, using Android Studio, you create Android applications. And I have been using Android Studio since the year when it was announce that this is the recommended IDE. The base of this Android Studio is IntelliJ, and on the top of that, Android Studio is created. Apart from the basic features like auto completion, refactoring, splitting the code files horizontally, vertically, and other things, it has some extra features that are only Android specific, and you will love them and you will need them a lot, like Layout Inspector. It helps to analyze and optimize the UI, the XML UIs. It also has a database inspector. So in database inspector, you can actually see the data which you are storing in the SQLite DB, or you can say RoomDB. You can run queries on that data, modify the data, and that data will even reflect in your app if it is running at that time. And if you are using live data or flow, which is constantly listening to the data changes, then the data will reflect in the UI instantaneously. Otherwise, it will be updated when you next time reload the application. Once you have lost the connection to the application in Android Studio, you can still opt to debug your database, which means that no matter your app is running or not, you can actually run queries on the data. It also has a network inspector, which actually tells you what all network API calls are made and what is the request and response of that, how much data was downloaded, how much data was sent to upstream, and all those things. By using background task inspector, you can actually see the work scheduled at some point of time, if they ran or not, whether they failed, in between, at what stage they failed. So all those things you can see in background task inspector. Other than these, you can also actually analyze the built files, which is the APK. You can analyze the APK and further improve it to reduce the size of the APK, which is actually shipped into the Google Play Store. It has a VCS integration of Git, so you can work on Git repositories within the IDE. Of course, it has terminal as well. And recent advancements in the IDE is emulator, which is integrated in the Android Studio. So while creating tutorials, I actually find it very important, very useful that I can, on the right hand side in the same window, I can show you what is in the UI, and on the left hand side I can show you the code. So it's very useful for that purpose. And also when you are working on Jetpack Compose, when you create those composables, which are small UI elements, you can see them live in the Android Studio. You can interact with them in the interactive mode, and now in the recent advancements you can actually see animation happening there and you can analyze the animation. So that's a very good feature. Managing a project structure, keeping it well maintained, and having a architecture for your application is a different paradigm, and creating UI in Android, its in own senses, is a completely different thing. Since Android's inception, UI is created using XML. There is always a companion file, which is, you can say, companion class, which is either written in KOTLIN or Java, which has references to the UI elements that you declare in the XML file. You can read and write value to those elements. There is a huge set of UI elements already defined in the Android SDK, which you can use to create layouts like text view, edit text, radio buttons, spinners, linear layout, frame layout, relative layout, recycler view, list view, and coordinator layout, constraint layout, motion layout, etc. Now you might be feeling how old school is creating UI in Android. You have Flutter where you have declarative, you have only one file. You have Swift UI where you have only one file to create UIs. So similarly, Android team is on the same path, and they are working since last 2 years on Jetpack Compose library, which is actually a declarative way of writing Android UI. And doing animations in Jetpack Compose is as easy as you are doing animations in Flutter, if you are working on Flutter, if you know Flutter. Otherwise, let me compare it with XML way. Doing animations in XML was little harder or way harder, but in Jetpack Compose, it's easy, intuitive, and very awesome. I have myself created a tutorial on animations on using Jetpack Compose. The same animation I have created on Flutter as well as on Jetpack Compose, and believe me, the number of lines that I have written in Flutter, of course, Flutter build will be compiled to iOS and Android. The number of lines on an average, Flutter is using lesser lines and building for more platforms, but the number of lines that I used in Jetpack Compose were lesser than I used in Flutter. So I can say the easiness of creating animation in Jetpack Compose is almost at par with Flutter. I'm not comparing, just I'm saying the way it is easy in Flutter, same way it is easy in Android as well. So to brief, Jetpack Compose is Android's modern UI toolkit. Now, how to create XML, how to create Jetpack composables, it's totally up to a new tutorial or other tutorial where I can teach about how you can create UI using XML or composables. Just remember there are two ways to create UI. Now we will see how data is stored in Android applications, how you can store it, where you can store it, and which type of data can be stored using what library. And as usual, since Android's inception, there are many advancements, many improvements happening in the department of storing data in the Android applications. So I am going to cover on the latest things that are used and little bit on what was there before. To store relational data, you use SQLite DB in your Android applications. You could initiate the DB connection by using SQLite DB Open Helper class. And previously we used to literally write the create queries and all these queries, update, delete, insert, select, all these queries we used to write. But now there is a wrapper for this all, which also supports live updates, also has support for KOTLIN coroutines. It is just like ORM based solution, which is Hibernate for Java applications. It's almost like that. There are possibly three key things in room storage: entity, which acts as a table in the DB; DAO, that interacts with the entity and performs CRUD operations on that entity; and third is database, which defines DB versions, the tables that it will initialize. It also has support for migrating from one version of DB to other version. Now, this was all about relational storage. To store key value storage, you have a data store. Previously shared preference library was there, but there is a better version of that library, which is preference data store. To store key value pairs, you can use preference data store. It takes care of asynchronous updates and also follows the best practices. Of course, this is recommended by Android team, and data store is part of Jetpack. In the data source itself, there is one more thing: proto data store. To store data as an instance of data, you can use proto data store. Of course, this will not allow you to update the data partially. Like in SQL or Room, you can update the data partially, but using proto store, you will have to completely write data into the store and not partially. Of course, this is not relational, so it will not support referential integrity. And here you define schema using protocol buffers. Protocol data store supports type safety, which preference data store doesn't. Second most important thing which your app always have is to make a API call, right? So in Android, you use HTTP URL connection class, and with the help of that class, you make API calls. But with the recent advancements or need of any Android application where you have to deliver the stuff quickly, right? So there are wrappers for this also, which will help you as a developer to quickly make an API call by just writing some lines and reducing all the boilerplate code, and also caching the request internally automatically, and so you don't have to write the code to cache the request all by yourself because the libraries or wrappers are already doing it. Some years back, Volley was the library that was in talks very much among the Android developers, also referred in the official Android documentation. But now Retrofit has taken its place because of its less boilerplate code, and also because of its clean structure. Now in Retrofit you can actually annotate functions with @get, @post, and by this I think you will understand the meaning of this automatically. When you annotate a method with @get, the API call will be a get call. When you annotate with @post, the API call will be a post call. Of course, you can specify the path of the URL as well. You can also put some interceptors, like for every API call, if you want to record a log, so you can have a logging interceptor which is already created as a support interceptor. And you can also, there is a good support for parsing the data which comes from the JSON, which comes from the API. So you can use Moshi, JSON, any library and the adapters are already created. So by using just one line, you can actually tell retrofit to return you the data after parsing, and it will automatically do as soon as the response is fetched from the API. You have some more annotations like add path, add query. By the name itself, you might have guessed, add path is used for path parameters, add query is used for query parameters. Now, this was all about REST APIs. But what about WebSocket calls? Those are actually also important. For that, just like retrofit, you have a library called Scarlet. I would say there is almost no difference between these two libraries, the way as an end user or as a developer you will be using them. Of course, the implementations might be different, but the way you use it is almost same. Just the annotations have changed. Otherwise, functions are there and you just have to annotate those functions, and rest Scarlet will take care of it. So it has adapters, interceptors, and annotations for add send, for sending or receiving from the WebSocket. If you observe here, database calls and the network calls happen when the user is interacting with the application and is eagerly waiting for the response. That's a different story, that IO calls don't happen on the UI thread, but there are some tasks for which user can wait and can move to a different application, or even need not to be notified once that something has happened on his event. And these type of tasks are called background tasks. To execute a background task, you have a work manager. Again, it's a Jetpack library. These work managers ensure that the work is done exactly once, or however you have defined it to be happening, but it ensures that the work has been run without fail, even if the app is killed or you have restarted the phone or something has gone wrong. If for some reason work is not able to be completed, then there is a retry policy that you can also write, and you can tell work manager that you can retry these many times and at these many intervals. You can even chain multiple works together in a work manager, which can happen one after another and give you a success once all have been completed. And you can check the status of your work in the background task inspector, as I have said before. The diagram here depicts how you should be configuring your work manager to do a specific type of work. There is a concept of constraint in work manager, which allows you to schedule a work when your phone is idle or connected to Wi-Fi, connected to charger, etc. It majorly helps you in maintaining backward compatibility, because in the latest Android systems or Android versions, we have seen there is a lot of restriction in executing a certain task in the foreground thread in some versions. In the previous versions it was allowed, but from Oreo it is not allowed. So these are the restrictions which work manager already takes care of this. So you, as I said, it does the heavy lifting. All the Jetpack libraries does the heavy lifting for you so that you can focus on your business requirement. Now let's come to a very important topic. You have covered UI, you have covered database, network, background work. So the next important topic is state management. You as an end user might not know that your app is doing a lot of work when you are interacting with the application. It is constantly refreshing itself. And as a developer, you need to make sure that whatever the user is seeing in your application, the data is up to date there and not outdated. So let's consider a scenario of how much work the Android application is doing when you fetch players from a player API. Just take an example. You are fetching number of players from a player API. From the time user triggers this action, the app broadly does these following steps: convert user input to the request object, call the API, validate the response from the API, parse the response, provide the response to the UI. 5 steps it did, and I have talked in a very abstract manner, but these all steps are memory consuming, IO, and they will take time. While this all happens, UI will perhaps show a loader or a shimmer, and then you have to dismiss the loader when the response has come so that user can see the latest data. And this is what is state management. Initially your state was something, and once the API response has come, your state is something else. So this is what state management is. Now let's consider another example. Suppose a screen has two text fields, an email field and a password field. It has a bottom button, sign in. When user starts to type in email, the app has to validate the email as soon as he is typing or he has typed 2-3 letters. So after every character entered, the validation has to run. It has to show a message immediately if the email ID is wrong. This is also state management, where this time you are updating the UI with a message when user is interacting with the screen. Previously, user did a operation to fetch the players and it took some time for the players to come from the response. This time you are updating the UI immediately because there is no API call while validating whether it's a correct address, correct email address or a password is of correct validations like special characters, alphanumeric, etc. So how do you manage state in Android? The straight answer is with the help of view model. With the help of view model, you can store the data, whatever the UI needs in the view model. Screen can delegate its job to view model and then it can wait for asynchronously for view model to give the response back to the screen. Once view model gives the data back to the screen, the screen will update the data. Or if you are using live data, the observers will automatically update the UI. But why view model? Why not just keep the data variables in the KOTLIN class itself, which is for activity? Why you have to have a companion view model class for the activity? That should be your next question. Because view model is a lifecycle aware class. It survives the configuration changes. I will tell you one example of configuration change. When you rotate your phone, your application switches from portrait mode to landscape mode. This is called a configuration change. When this happens, the screen, the activity, destroys itself and recreates again. Now, if you have put the data variables in the activity, your activity instance is destroyed. So that data, which you have, suppose you have stored 4 characters of email and you have rotated the screen, the 4 characters will be destroyed, and once the activity is recreated, the email field will be empty. It will not be filled with those last 4 characters that you have entered before when the phone was in portrait mode. And you have lost the state basically. That's why a lifecycle aware component is important. View model survives this configuration change. It has a larger lifecycle than the activity with which it is associated. State management is a very huge topic and it is done very differently when you are doing UI using XML or Jetpack Compose. The concepts are little different. So I'm skipping this for another video. Just remember that a view model prepares the data for the UI and UI observes live data which is present in the view model. Or instead of live data, you can also use a state flow, which is from KOTLIN. Now I have told live data many times without explaining what is live data. So let's touch base on live data a little bit because that is also an important part in reactive programming. So live data is an observable data holder class that is based on observer pattern. When the underlying data in the live data is changed, its observers get the callback immediately. This also resolves problems for memory leaks. Let me give you a quick example. Suppose you were updating your UI, but the method which was written in the activity class is destroyed because your screen is rotated. And while rotating, you are trying to update the UI. So the context is lost, the activity is lost, and you are still holding a reference to the activity. So that is what is memory leaks. With live data, if activity is destroyed, the observers written in the activity are also not there, and hence UI will not update. Live data will not supply any updates to the observers. Instead of live data, nowadays KOTLIN Flow is also used. You can use both of them together in a single project, that's not a problem. But KOTLIN Flow is more advanced to live data because it handles asynchronous operations as well. Live data is also lifecycle aware like your view models were. So now that you know about view model, live data, database calls, network calls, background task. So let's move to clean architecture. Clean architecture is used to create scalable applications and maintainable applications, where you clearly define the boundaries of who can access what in a project. It encourages high testability of your components You can write 100% unit test cases, terms and condition applied. It also encourages parallel working. When you have a team of multiple developers, you can divide the task of different layers and then achieve the task together, because every component has a specific role to do. So developers know that this is the boundary of this component, so my work ends here and the rest of the work will be done by the other developer. So that way it supports parallel working. A clean architecture majorly focuses on object-oriented programming concepts like abstraction. Like as I said, there are typically 3 layers: data, domain, and presentation. One layer is not aware of how the other layer is doing its work. It just knows that what it needs from the other layer, but how that other layer is giving that data, it's not aware of that. So let's start to understand what all falls. These view model, live data, your retrofit, your network layer, database layer, where all these fit in the clean architecture. So presentation layer consists of majorly 2 things. First, UI creation, and second, state management. UI elements are the UI views, your activities, your composables, your fragments, and all those things. State management is done by view model. So you will store view model also in the presentation layer, that is UI layer. So this is called a state manager. If you want to keep entities or models in the UI layer, you can keep them, but they will be solely solving a purpose to update the UI or basically encapsulating a huge set of data so that the UI can understand it with one reference. Remember, UI has to be dumb classes. They just need to update the UI with some data, that's it. They don't have to write business logic. They don't have to do some complex operations while on the UI. Theming, colors, shapes, etc. are part of your UI layer. For state managers, view model is one that we can denote as a state manager. You can have something other like presenter, which actually is a MVP pattern. In Android, we follow MVVM, model view model, and MVP was before or still there together with MVVM. Instead of view model, you have a presenter here. Of course, presenter is not a lifecycle aware component, but you can make it lifecycle aware component. And as explained before, view model's responsibility is to provide the data to the UI in whatever format it can. View model can also help prepare the data for the UI. So suppose it has got a response from domain layer, but UI layer needs something else. So you can use mapper and map your domain model to your UI entity, and you can give it to the UI back. Now let's come to the domain layer. Domain layer is optional as per Android official documentation, but I think it's important because with domain layer you can actually effectively separate out your layers. You have a clear domain layer acts as a mediator between presentation layer and the data layer. So whenever UI has called view model directly calls use cases after doing some work if required. And when use cases are called, use cases actually call abstract repositories, the interfaces or the abstract classes only. The actual implementation of the methods present in the abstract repository is found in the data layer. So the calls will be abstract, but they will be eventually called in the data layer. A use case is an atomic piece of functionality in your app, like validating a password. So a use case interacts with the abstract repository. It calls a method in the abstract repository. To improve testability, abstract repository is created in domain layer, which is then implemented in the data layer. In domain layer, you can also create domain models that only hold the data that is required for your app logic. So typical example would be if your API is returning 100 fields from the response, but your app needs only 5 or 10, then you will have a domain model that will store only 5-10 fields. So let's move to data layer quickly. This layer does the IO operations mostly, like making network calls, making database calls. Now, remember abstract repository from the domain layer. You have to implement the abstract repository in the data layer. Typically, repositories are there to return data either from data layer, either from database, or from network response, or from network. For each of these, database or network, you actually create data sources. Like if you have to interact with database, you create local data source. If you have to integrate with network, talk with network, you create a network data source or remote data source. You can also keep DTOs in this data layer because whatever objects are coming from network or database, you have to store them somewhere. So you will create DTOs there as well. You then use a mapper to convert your DTO model to a domain model so that the use case who has called the repository method can get the domain model in return and provided that to the caller, that is view model in this case. From view model, you know that UI will update itself because it is observing the live data or KOTLIN flow. I understand theoretically it might not be completely clear to you unless you see a project in place. So to get more knowledge on this, I already have created a complete movie app in Flutter, but that is in Flutter, which also follows clean architecture. I would say you can understand little bit about clean architecture using that code, because clean architecture concepts are actually same. It's a architecture. It can be used in any application. So it's not bound to be used only in Android or only in Flutter. So you can take idea from there. If you wish that I should teach you about clean architecture in Android, I'm more than happy to do that. And I eventually have a plan to create clean architecture videos for Android application. So now the most funniest part, dependency injection. You have so many components. You have view model, you have a repository, you have data source, you have activities, you have Moshi, you have many things, retrofit. All these have to be initialized, have to be dependent on something and be a dependency for someone. So dependency injection is very important topic. It tells you that you need not initialize the variable or the object every time you need it. Instead, somebody else can give it to you if it's already initialized before, or not always initialized before. It can at the runtime, at that moment, can initialize it for you and give the instance of it. So that your component, which is dependent on the other component, can be start working. In Android applications, you can add dependency injection by using Dagger 2 or Hilt. Hilt is more advanced version of Dagger 2. It is created on the base of Dagger 2, but it is solely created for Android applications, keeping in Android applications in mind. Okay, because it understands what view model is, it understands what Android application is, it understands what is a work manager, it understands what is a activity, what is a service, what is a fragment. So all these dependency injections it can do automatically for you. You need not define them specifically. So Dagger 2 can be used for any other application which is written in Kotlin or Java, but Hilt is specifically for Android applications. With this, the mandatory part of this video is completed. Now it's up to you to watch this video further till the end, because I am going to cover 3 more libraries that I feel are also important. So let's talk about them quickly. Navigation. So when you have a big application which has many activities, where there are screens which have multiple entries, like you can enter a screen from 2-3 places, you will often have to look at the code to understand from where the activity is launched, who has triggered the launch of that activity, what is the flow of this screen coming to that screen or any other screen. With navigation library, you get a graph that depicts the entry and exit point of a screen. It also tells you about the entry and exit animations that it is going to perform when it is entering a screen or exiting a screen, what type of data it will show on the screen. You can use sample data for that. Next is Glide. It's a awesome library to actually load network images, and it helps in choosing it actually caches the images very well. It follows best practices, and it is also a recommended library. It's highly configurable. And the last library is a paging library. Paging library is also part of Jetpack, and it helps in loading data from large data set, either from network or database. This ensures that the data which you are loading is a paged data, and it's using system resources efficiently. So again, following the best practices which are required for implementing a pagination. With this, I close this video. I believe with this guide or an overview of modern Android application development, You will get an overview of how it's done and you will feel motivated to start Android development. I wish to cover many more topics in depth in Android. So subscribe to my channel for more videos on Android. Support this video and the channel by liking this video and sharing across your circle. Thanks for watching and see you in the next video.